Hello.
How are you today?
Good, good. How are you?
Yeah, good, thank you. Well, thank you for joining me for um, this recorded episode of
No
Points,
worries.
Lines, and Polygons. I do appreciate um, you taking the time um,
Mm.
to do this. Like I said the
No,
other day,
it's my pleasure.
didn't want to interrupt your work. Um, so we'll record this one and then I'll put it into that people can watch it at a later stage. But
Mhm.
so welcome. I have my note taker going in the background,
Okay.
so and recording it, so we can just chat. But yeah, just um, I'm not sure if you've had an opportunity to watch any of the
Yeah,
previous
I did
episodes.
watch. I did watch, not completely, but partially. I did watch some of
Yeah,
the
nice.
videos. Yeah, yeah.
All right. Um, so yeah, so
Mm.
basically, it's really a chat
Yeah, yeah,
about your career, how you got into spatial sciences,
yeah.
and in essence, I'm happy for you to go as far back as you really want to,
Yeah.
because I noticed what I think is quite interesting is one, um, you've started your journey from a physics background, maths and
Yeah.
physics background, um, and um, and so I'd really love to understand what you did,
Yeah.
back
Okay.
then, how you ended up in Australia, the things that you've studied, and and I guess part of the towards the end of
Mm.
it, the struggles that you found in trying to
Yeah, yeah.
secure a job in the spatial industry here in Australia. So yeah, so happy for you to start wherever you like.
Yep, yep. Yeah, I will tell you my background because background is important. So, but the thing is, yeah, I'm not a GIS specialist. I'm GIS graduate and still looking for a job. But yeah, I did bachelor's in physics and I have completed master's in physics as well. In my master's, I did classical molecular dynamic simulations. This is basically the theoretical modeling of the material, like you simulate the material, and this is a kind of prediction. You predict what will be the structure of material, symmetry, boiling point, melting point, and all these physical quantities, and at what temperature this material could be realized in laboratory. So that was exactly kind of predictions, the theoretical modeling of material, but that was classical, not quantum mechanical modeling. Quantum mechanical modeling is different. That, uh, but I don't want to go much in that detail. Yeah, so I did that, and that was really interesting, and I found it interesting as well. And because I love physics, I love physics. I'm a physics person, so because after that I started teaching physics in school and in college to actually improve my concepts, the basic concepts of physics, the basics models of physics. What so I've been teaching those things at school and college, but that was more about teaching. It's like you solving the numericals, solving the integrals, differentiation, trigonometry. So all this stuff, mostly you are doing something on board or stuff, but you don't know. I was curious what is going on in uh, industry, like in technological industry, what is going on, because people are doing jobs from 9 to 5 in industry and going on, because I was doing something different and I was curious what is going on there. And yeah, because otherwise if I'll do PhD in physics, so I'll end up in teaching physics in university or doing like research or stuff like this. So that's why at that time, at that moment, I thought, okay, so what is going on in technological industry and what's over there? So, and I studied a course in my bachelor's that was satellite remote sensing, and I was curious about that at that particular time course because that was uh, much of theory, not theory means not mathematics, like a kind of concepts or overview how satellite remote sensing works. And at that time, I asked professor that uh, you are saying that the satellites captures the data above from the Earth's surface, and if satellites miss the data of that particular area, so what will happen? So then he explained, oh, we got hundreds of satellites and they have different orbits and stuff like that. So I said, okay. But at that time, I didn't know like how it worked, like how what is going on in industry. And out of curiosity, so I was thinking, so what is this field? And the other thing is, at that time, back in my home country, there was a situation of flood. Flood was everywhere. And I heard from someone, and oh, so we can do risk assessment of flood areas like through GIS. So I said, oh, bro, how you could do that? So I was curious, like you are actually trying to figure out which are the high risk areas for the flood. So I was curious about that. So that guy told me we can do it through GIS, and we are doing this as well. So
Nice.
yeah, that was curiosity as well. So what is going on? Because GIS was not part of my agenda, so I will do GIS. And uh, but out of curiosity, so I was thinking I have to like shift my job routine. I have to do something which is in what is going on in technology, and people are doing 9 to 5 jobs, and what are they doing? So yeah, that was a kind of curiosity to me. And then I
Was
thought,
that curiosity? You're still doing your physics stuff at this stage, or did you
uh,
finish your physics?
no, I'm still in touch with physics, uh, because physics is in my roots, like I could say, because physics, I believe, or physics is actually the foundation of science. Most of the sciences originate from physics, and mathematics is the language of physics. So mathematics is the language of universe as well. So that's the beauty of mathematics. So yeah, I'm still much into that, and I was much into the latest theory. I sometimes look into. We got latest theory, string theory. Now we can't test the string theory, but still we know that that is the string theory will tell us the overall the model of universe, like on the same level, because. I'll tell you a little bit about because classical and quantum mechanical models work at different scale, like on our scale, like stars and Earth, or like human level or ball or something. So this is classical level, classical molecular dynamics. So they work for there. But at quantum level, so we go really at downscale, like 10 power minus 8, minus 9. So where quantum mechanical effects appear. So the two areas of these fields are totally different, but we are looking for one universal theory, which is the string theory, that is the candidate that can work in both areas at the quantum level and this level as well, like macroscopic level as well. So yeah, I'm still into that as well. Uh,
And are you trying to then bring the physics and the GIS and remote sensing together, or is it just that your interest is running parallel?
Now, actually, the thing is in GIS, because I will tell you, because when I started GIS, I started studying GIS. So at that time, I shared this post on LinkedIn as well. So at that time, I realized, oh, bro, so if they are doing like uh, everyone is producing map, so every single map is different from every. any other person. So, but in physics, for example, if I'll have a ball, and if I know the initial velocity and time taken and distance, I will exactly tell you the final velocity of that ball and the position. So it doesn't matter if you are solving this problem or someone else is solving this problem, we will all come to the same conclusion. It doesn't matter who is doing that. But here, everyone got different maps. So everyone got different outcomes. So, and there is no perfect such thing, and there is no perfect model to whom we can compare. My model is better than this one because there's no such perfect model for comparison, because that's because mostly human judgments are involved in this. So you will draw that map. You could say that my map in that particular aspect is better than yours, or you could argue that thing. But still, at that point, I felt, bro, so everyone is going a different outcome, producing different outcomes. So I was curious because in physics, doing this thing, so get the same answer. That's it.
Yeah.
So,
It, it is a
mhm,
really interesting, you know, and so much of science, I guess, is black and white in that respect. There's
yeah,
an underlying theory or relationship or however it works. And as you said, like in physics, you'll
yeah,
if everyone does it, you'll come up with the same result.
same answer.
And and I guess, you know, the same with, you could give everyone the same data and the same problem from a GIS and mapping perspective. But yeah, as you said, the result is then up to your interpretation
Yeah,
of what that data is coming in, how you want to present it, and then the result coming out. And the result coming out might, the actual analytics of it might be the same, from person to person,
yeah.
but the visual of it is always going to be different. So,
Yeah, it could be different. Yeah, yeah, you explain in a better way. So, but yeah, that's why I'm saying, but still one guy can prefer that map or other guy can prefer that map. They can say, I want to see that thing in there. That also this differs. So then like I realized at that time, because that was my first impression, and then I said, oh, this is kind of surface knowledge. We are not going into depth. For example, like I studied course Advanced Space-Time Analysis in GIS. That is actually the course where you study the different techniques, interpolation techniques and stuff like that. But the thing I got the missing part was, for example, if you're teaching some particular technique, interpolation technique, so then you have to present the mathematics of that model. So if you're presenting mathematics that model, then it does make sense to me. Apart from that, if you are giving an overview, like, yeah, this model is doing this thing, that's fine, that's fine. That's totally I get it. That's going on. But the depth is like if you're telling me these are the equations, this equation do this equation do this, and this is how this model works. So that thing was missing. So I said, oh, this is missing. So it was kind of like a black box to me if I'm giving you data. Like I'm giving like input and taking out output. So that's kind of black box. I can't do really much to change that particular technique because I don't know exactly what is going on. I do know, but I don't know at the same time
yeah.
what is going on.
And I think that inquisitive nature that you obviously have from the physics and science is wanting you to delve deeper into how the whole GIS maths work behind the scenes, because it is still, when we're talking about a curved earth and
Mm,
you've got the different mathematics on the curve, and I think it's great to hear like someone like yourself who really wants to delve into it, because the software these days, it makes it so easy to just click a button
Yeah.
and you're outputting a map. Now, is that map correct? Is it the right, have you used the right projection as an example to produce that map? And if you don't understand the underlying maths or rationale behind it, then you'll put something out and it might look okay, but it may not be right. And I think that's a really, really good thing from your side, is that, wanting to understand what's in that black box.
Yeah, so that was at that time I felt that this thing is missing. But mathematical models were missing in that studies. That I felt. Or maybe this is due to the reason because most of the time they are dealing with software, producing maps and stuff like that, processing the spatial information through different ways. This is part of the reason as well. But I was like, but I need that thing as well. I was more curious, like, what is going on exactly? Because in interpolation, I studied, uh, you can do predictions through interpolation technique by using curve fitting, and that's the power of mathematics. Like you can do predictions, and but the limitation of that method was you are doing predictions purely on the previous data. That could not be correct because, for example, if you're mapping the temperature, like of particular environment and area, but you got the data of previous states, and you are on the basis of those, you are predicting the temperature, but still there's a limitation because there are no inputs which exactly accelerate or exactly like changes those situation. uh, that so you know what I mean. So
Yeah,
purely based on data, yeah, it's different thing. And
yeah,
input, yeah, input, because that input comes when physics comes in. So then you put those inputs in simulation and then you predict. So mostly, so yeah, that thing our also I found that mathematics is missing. Mathematical models are missing, and which gives the foundation of the whole thing. So if you are doing software, because other you can't bring any major change if you don't know what is going on inside, because
yeah,
and you can't exactly figure out the error. So because you don't know exactly what is going inside in that particular software and how is it dealing with the things. So that's the thing I felt, and but still I tried to do my part in that because I can't do much because if I don't understand at the same time, if you are studying 4 courses, so you have to pass as well, and meanwhile you have to work, and so you can't pay that much attention to any particular course so to do much. And then I did because the other thing the other course that was interesting, that was spatial information management. That was good. In that course, we actually modeled the building of spatial sciences of Flinders universities. Like we have to create the windows, doors, and stuff like that. And that we really learned the software because we did that in ArcGIS Pro. So at that time, I really learned like how to create these things and how to remove that. And so that was interesting. And at that course, I created COVID-19 dashboard as well. So mm, and then I realized how to manipulate the data and stuff like this. But yeah, overall, in apart from that, in my final year, uh, I did thermal mapping of Adelaide metropolitan area.
yeah,
So I, because this was this project was different from everyone's else due to the reason because I wanna do this because that was close to physics because there's temperature involvement in that, and that kind of feel me like, oh, I'm not apart from the physics field. I'm close to that. So I'm trying to link that as well, because temperature is physical quantity. Temperature, because it's proportional to average kinetic energy of molecules. But in that, the definition of temperature is different. Temperature is actually the a partial derivative of entropy with respect to internal energy, and that's statistical definition of temperature. That's different, but that's good as well, because uh, I like that stuff, because uh, when we talk about physics, so precisely because mathematics is the language of physics, so you can't describe the stuff physics, like physical quantities even, without using mathematics. Because if I have to, for example, I have to describe the force. If I'll say to someone, describe force without using the equation of force, so it's it's very difficult. It's a very
Yes. Yep.
difficult task. So yeah, so I wanna relate that thing to physics as well. So I said, because my professor was David Bruce, he's the associate professor at Flinders University, and he kind of know physics as well. So yeah, I asked, can I do that? So he said, yes, definitely. So I could not do like very well in that particular project. There are some other things as well, but still, that was a mapping of early metropolitan area, because and I did ground validations in that project as well. On different particular sites, I went there and I took some readings through the machine that I don't know what was that particular machine, what is TIR detector. But I found that in at that particular readings, when I was doing reading. So if you're taking temperature measurement from different angles, temperature changes.
Yep.
So if we are doing from the satellite, so yeah, there's a lot of noise in between and stuff like this. I did perform this through two methods: a single channel and the other is split window algorithm. Uh, Basically, not exactly I use the split window algorithm. I use the simplified form of that algorithm because I could not figure out the atmospheric corrections of that day, and those were really necessary when you mapping the temperature through TIR imagery of satellite, because I have used the TIR imagery, thermal infrared imagery of Landsat 9 satellite, and then by using that, I discovered like this is the temperature of this and that particular the whole map. So yeah, I use that thing particularly in because I want to close to my physics field as well. And apart from that, I did machine learning in one course. I really like that machine learning because I for use that for classification purposes, machine learning. And the thing is, that was kind of AI, because machine learning
Yep.
is AI. So, but you have to give inputs, and the output depends on your inputs.
Yep.
Like how many uh, how many modules are you giving in? Like 100, 120. How many precise and accurate things are you giving in? So your output depends on that. So in machine learning, yeah, you are training the model. So
Yep.
how to perform exactly. So I that I like that machine learning algorithm as well, but I didn't use it in my final year project because I can't use it because that was a different technique, different approach to model the temperature. But I like that. But yeah, overall GIS, overall GIS looks a kind of surface knowledge to me because I found depth is missing, And because if you want to work on something, because if you want to work on one algorithm or any interpolation technique, so it takes time. So it takes time. So you have to go to really deep into that. You have to like write the mathematics and discover what's going on exactly. So it takes time because apart from the reason like in courses you don't have that much time. Mm, maybe this is the thing, they are not much focused on the mathematics behind that. But yeah, to me, overall GIS is still a good experience. It's a good experience, but I'm more interested in basic questions, like fundamental uh, questions. For example, now the series of this episode is points, lines, and polygons. And points is zero-dimensional thing. We It's not exactly zero-dimensional, but we could say like, is it?
Yep.
It's zero-dimensional, and line is one-dimensional. Exactly. And the polygons is two-dimensional things because we can discover the forest boundaries and stuff like that. We can easily map the two-dimensional things from this. And from these two dimensions, we create three dimensions in that as well. And that's our limit. That's our limit. Three dimension. We can't think beyond three
No,
dimensions.
no, there's certainly um, it has its limitations, and certainly there's plenty of, you can add that an extra dimension of like time, or to get, how has this changed over time. Uh, but it, but I really like the way that you look at it, and I think that's really quite different to everyone else that I've spoken to. It's how can I get that information to a lower level, and being able to look at things like, the satellite imagery, and see what its limitations are, and go, how can I improve that? And that really, I think, is really um, great in your scenario of how you've brought your previous studies and interest through to where you are now. And and so you've finished your degree or your master's in GIS now from Flinders?
Yep. I did finish, like it's about like I just did finish in December 2024. So
Right, yep.
it's
Oh, it's been a couple of years now.
yeah, it's
So
almost 1.5 year I did finish, but yeah, I'm still looking for a job because yeah, special industry, how it's it's going on.
yeah, and it certainly can be hard from time to time in terms of trying to find that real um, connection between not just being a job, but also being interesting as well. And some of those things could be, you touched on what really got into you interested is that, that flood modeling and things like that. So um, certainly South Australia probably doesn't have, it has flood issues, but it's probably
Mhm.
not a major
Not a
problem all the
major issue.
time, as opposed to um, potential things like fire modeling, which it has a greater impact.
Mhm.
You know, each summer there's normally a number of bushfires somewhere,
Number of
and so
bushfires,
that
yeah.
may be one thing that you can try and bring those things together for different organisations. The Department of Environments, or even the Country Fire Service, has a GIS team and things like that. So I think I think, it's it's obviously an interesting journey that you've had from your home country to Australia, and trying to convince people that you've got those underlying skills, and that you can build on it. And so where do you want to take your career from here? Do you want to try and, build it in Australia, or is your ultimate plan to go back home, or is it to stay in South Australia or wherever? So,
Yeah, the first thing is first I have to get job here
yep.
to get experience, some experience like how like GIS industry, how it's working, like what's going on in the industry. It's because I have studied and I have seen this and that, but still on in industry perspective, like what is exactly going on and what these guys need and what we can improve. So the first thing first is I have to get job like into the field and then because I have applied for job like bushfire special analyst, but
Yeah.
I'll see how it goes. But still, you have to apply and then
Yeah.
mm, because most of the time they require an experienced man, so experience in that particular field or this and that. So it's really hard to make an interview. So, but still, that's my first priority to get job into my field, and then I will see what can I do in that field. How can I improve in that particular area? So what's going on, what I can do, and what I can really improve in that field. Like how can I benefit? And in the long term, I will see like after 4 years, 5 years, um, maybe I will planning to or like build my own company or stuff like this. So
Nice.
in the long term, because if you're doing job, all at the end of the day you're stuck somewhere, but you have to do something.
Yeah.
So yeah, so first I have to get experience. I have to get some expertise, skills. I I will mm, I I'll I know what I can exactly do and what I can change, but once I'll into the field and then I can look at different directions and long term I will see what I can build my company or I can do GIS stuff on my own as a freelancer or stuff like this.
Yeah.
Yeah, so this is a long
It's good.
term plan, and it
Yeah.
could be here, it could be back in my home country, it could be anywhere. So,
Yeah.
uh,
And that is one of the really good things about GIS is that you can do it anywhere, and because the underlying fundamentals of it is the same. The same as your physics stuff. Physics doesn't change because you change country. Uh, it might change if you find a black hole somewhere. Uh, but here, and the same with GIS, it's the same as Australia. It's the same in England, as in New Zealand, as
yeah,
in Pakistan or wherever,
yeah, everywhere.
um, and so it's. I think that's a good positive about choosing a career that actually can be used for a whole range of uses and in different environments, and so yeah,
Yeah, because now GIS is the like integral part of every industry. Wherever you
yeah,
go. So you'll find one GIS person, one or two, because that's working in that industry because it is everywhere in transport, in environment, in like in everywhere. So in every single field, we can find GIS person because they need GIS in that field. But the thing is, it depends what are the requirements, what they wanna need from GIS person, what they exactly want, and because in industries they are more focused on their results, like what they want. They don't uh, want a major change in industry or stuff like this. They want to do their routine works, what they can do for the clients. That's it. That's the thing. But if you are approaching GIS as a researcher or stuff like this, then you can bring any major change. Uh, because if you because major change could be at the foundation level, could be at different level. It depends. But if you exactly know the foundations, then you can bring any change. Or Otherwise, if you are industry, because industry needs a particular uh, work from you, like you have to do this and that, produce this, and this is the outcome. So give us. So that's it. Our clients need that's the industry work. But if you will approach through as a researcher, then that's different thing. Then you can think out of the box, like what you can exactly do in this field to bring any
Yeah.
particular change.
And maybe that's actually a good way of, like, yes, there's the academic path and the industry path, but there's also, I guess, that combination, organizations like CSIRO, very science focused. They do a lot of GIS work. So, and that really is that crossover of academia and
Yeah,
industry. And even, at a national level, organizations like Geoscience Australia, there's a lot of research that goes on into their day-to-day things. So I think there's great things ahead for you. I think we've just got to keep on working together to try and find that job for you, and then see where it goes for you. I think there's some real positives there, um, and yeah, I mean, we we might wrap it up there. I think that's
yeah,
been terrific.
yeah,
Um, and I hope we can help you further, both from a together
I
spatial point of
appreciate that.
view and a GIS jobs point of view, and just start making those connections, and get you that first career, that first job opportunity here in Australia, in South Australia, or, in Adelaide. So
Yeah, I appreciate that.
appreciate your time today.
Yeah, I appreciate your time and your inputs. So yeah,
All right. Well, you enjoy the rest of your evening, and we'll chat again very soon.
yeah, we'll chat again soon. Thank you, thank you.
All right.
You too.
Thank you very much. Okay. Bye for now.
Thank you. Thank you. Have a good day.